When you derive t cube, you will get 3t square. T square is considered as 2t and t is considered as 1. So you can take the parameter as t here. When does the car stop? Means we need to find out the time here. So to find out the time, let me take v is equal to 0 because we always consider the final velocity as 0. When you write r cube, when you derive it, you will get 3r square. So 3 get cancels. We are left with 4 pi r square into dr by dt. Hello everyone, a warm welcome to one and all. This is Vidhyaashram ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to revise the chapter Application of Derivatives. So, the questions you can expect from this chapter is from 2 mark as well as 3 mark question. Let's see the distribution of marks from this chapter. So, you will be having 1 2 mark question and 2 3 marks question. So, totally 8 marks from this chapter. So, your 3 mark questions and 2 mark questions will be based on the rate of change of quantities, maxima, minima, increasing and decreasing function, as well as application of derivative towards commerce, that is the cost function and revenue function. So, let's see the questions in 2 marks. The displacement S of a particle at a time t is given by S is equal to 4t cube minus 6t square plus t minus 7. Find the velocity and acceleration when t is equal to 2 seconds. We know that velocity is change in displacement. The change in displacement is given by ds by dt. So, we are finding the velocity. So, ds by dt means you need to derive the function s here with respect to t. So, when you derive t cube, you will get 3t square. T square is considered as 2t and t is considered as 1. So, you can take the parameter as t here. So, therefore, here you will get it as 4 into 3t square minus, next we have 6 into 2t plus 1, and as per as minus 7, it's a constant whose derivative is 0 there. Next, we need to find the acceleration also. So, let's see the acceleration. Acceleration is change in velocity, that is we can write it as dv by dt a. So, dv by dt, or we can write it as d square s by dt square, because velocity is this equation whose value is 12t square minus 12t plus 1. Now, therefore, acceleration become t square is 2t. So, 12 into 2t minus 12 plus 1 is 0. So, we will get this as 24t minus 12. They have asked us to find out the velocity and acceleration at t is equal to 2 seconds here. So, therefore, velocity is 12 into 2 square is 4 minus 12 into 2 plus 1. So, therefore, it will be 24 plus 1 whose value will be equal to 25. Next, here we need to find out the same at t is equal to 2. So, 24 into 2 minus 12. So, 48 minus 12, we will get this as 36. Next question. When the brakes are applied to the moving car, the car travels a distance s feet in t seconds, given by s is equal to 20t minus 40 square. When does the car stop? So, car stop means the final velocity. So, we consider the final velocity as 0. So, before considering the final velocity, let us find out the velocity of the car here. So, they have given s is equal to 20t minus 40t square. So, let us find change in displacement, that is the velocity. So, which is 20 minus 80t. Now, here, so when does the car stop? Means we need to find out the time here. So, to find out the time, let me take v is equal to 0, because we always consider the final velocity as 0, because they are saying the car stops. So, therefore, 20 minus 80t we have, or we can say 80t is equal to 20, t is equal to 20 by 80. So, which is 1 by 4, or we can take 0.25 seconds. So after applying the brake, the car stops after 0.25 seconds. Next, the radius of sphere is increasing at the rate of 0.5 meter per second. Find the rate of increase of its surface area and volume after 3 seconds. So here we are talking about the sphere as well as the surface area and volume after 3 seconds. So what is the surface area of the sphere? So that is surface area is equal to 4 pi r square and volume of a sphere is 4 by 3 pi r cube. Now we need to find out the rate of increase, that is change in area as well as change in volume with respect to time. So if I derive it, it as dA by dt will be equal to 4 pi is a constant. R square when you derive with respect to t, it becomes 2r. So here 2r becomes 8 pi r into dr by dt. Because we are not deriving t with respect to t here, we are deriving r with respect to t. So we need to write dr by dt here. Similarly, change in volume can be written as dv by dt. So here when you write r cube, when you derive it, you will get 3r square. So 3 get cancels. We are left with 4 pi r square into dr by dt. Now they have clearly mentioned here the change in radius is 0.5 meter per second and the radius or the time interval 3 seconds they have given here. So now here they have given time, but here we need two parameters, one is radius and one is dr by dt. Change in radius is already they have given, that is 0.5. Now we know that here dr by dt is 0.5. Time interval they have given, that is after 3 seconds. So let us take dr is equal to 0.5 into 3, which is equal to 1.5. So therefore we will take dr approximately equal to r we will take here. So r can be 1.5 here. So here we will get this as 8 pi into 1.5 into 0.5. So therefore this is equal to 6 pi. So since this is area, we can write this as meter square per second. Next we have volume. Here also we have 4 pi r square into dr by dt. So therefore here we can write this as 4 pi 1.5 whole square into 0.5. So therefore this is equal to 4.5 pi meter cube per second. So since this is volume, we can write this as meter cube. So this is the change in area as well as change in volume of a sphere. Next, the sum of two natural numbers is 48. Find the numbers when their product is maximum. So let us take the two numbers as x plus y is equal to 48. Then y I can write it as 48 minus x. So they have given the numbers when their product is maximum. So let us consider the product as p is equal to x into y. So we will take y as 48 minus x. So we will get the product as 48x minus x square. Now we are talking about maximum. Their second order derivative must be negative. So let's check it here. So we will take dp by dx is equal to, when you derive it, you will get it as 48 minus 2x. Now d square p by dx square will be equal to minus 2, which is less than 0. So therefore the given function has a maximum value. So such that we can put here 48 minus 2x as 0 now. So we will get 2x is equal to 48. So x is equal to 24. So if I get x is equal to 24, then according to the equation we have y as 48 minus x. So 48 minus 24, we get y also 24. So clearly you can see the sum of the two numbers is 48 and the product is maximum. Next, find the average cost and marginal cost for an output of 10 units if the total cost function of an article is given by c is equal to 5x square plus 2x plus 3. So x is equal to quantity here. So here the cost function is given, c is equal to 5x square plus 2x plus 3. So I need to find out average cost. So the average cost is the total cost function divided by the quantity variable x. So if you divide the whole equation by x, I'll get this as 5x plus 2 plus 3 by x. Next, I need to find out the marginal cost. Marginal cost is the derivative of the cost function. So therefore, when you derive it, here x square is 2x. So here you will get it as 10x plus 2. Now they have given here the output is 10 units. So that's such that we need to take x is equal to 10 units here. So if you take x is equal to 10 here, we will get 50 plus 2 plus 3 by 10 is 0.3. So we can write this as 52.3. So therefore, the average cost is can be taken in terms of rupees as 52.3, and here the marginal cost is 10 tens are 100 plus 2, so therefore 102 in terms of rupees. Next question. If the total cost function of an article is given by x cube minus 3x plus 7, find the average cost and marginal cost. So the average cost function is nothing but cost function divided by x. So therefore here we will get x square minus 3 plus 7 by x, and the marginal cost is the derivative of the total cost function. So when you derive it, you will get this as 3x square minus 3. Next question. A circular patch of oil spreads on water. The area growing at the rate of 16 centimeters square per minute. How fast are the radius and circumference increasing when the diameter is 12 centimeter? So whenever the diameter is 12 centimeter, we can consider the radius as 6 centimeter. And the diameter is nothing but 2 times the r, that is equal to 12 centimeter. Now they have given that the area is growing at the rate of 16 centimeter per minute. That means they have given the change in area, that is 16. Next, how fast the radius and the circumference increasing when the diameter is 12 centimeter. So let's see the circumference of the circle now. So circumference or the change in circumference is dc by dt, which is equal to 2 pi into dr by dt. So dr by dt, because 2 pi r we have here. So next here we have dA by dt, which is equal to 16, and area of a circle is given by pi r square. So when you derive it, you will get it as pi into 2 times r into dr by dt. So that is equal to 16 here. So now here we have r is equal to 6. So let us substitute here. So we will get dr by dt is equal to 2 1s are 2 8s are 16. So we will get this as 8 divided by pi into r we will get. So here it becomes 6, which can also be cancelled as 4s are 3s are, or we can write it as 4 by 3 pi. So centimeter per second we can take. So that is the change in radius. Now change in circumference is 2 into pi. dr by dt is 4 divided by 3 pi. Pi get cancels. So 2 4s are 8 by 3. Circumference is also centimeter per second. So therefore this is the change in radius and this is the change in circumference when the radius is equal to 6 centimeter. Next question. Find the maximum and minimum value of the function f of x is equal to x cube minus 3x. So whenever we are finding the maximum and minimum value, we are going to find out the second order derivative as well. So now let us find out, or let us take this as f dash of x. Let us derive. Then we will get here 3x square minus 3. So put f dash of x as 0 here to find the critical points here. So by taking this as 0, we will get it as 3x square minus 3, or we can write x square minus 1 is equal to 0, or x square is equal to 1, x is equal to plus or minus 1. So we have 2 points, one is 1 and minus 1. Now let's check it for f double dash of x. So here f double dash of x, we will get this as 3x square minus 3, we will get this as 6x. F double dash of x is 6x. Now at point x is equal to minus 1, that is f double dash of minus 1. We will get 6 into minus 1, minus 6. So here it is less than 0. So therefore f of x has maximum value. So at minus 1. So therefore f has maximum at minus 1. So therefore f of minus 1. So we have minus 1 whole cube, minus 1, minus 3 into minus 1 plus 3, which is equal to 2. So this is the maximum. Similarly, let's check f double dash of 1. So you will get 6 ones are 6, which is greater than 0. So whenever it is positive, that means f has minimum at 1. So let's check f of 1. So f of 1 is equal to, so 1 cube is 1, minus 3 into 1 is 3, which is equal to minus 2. So therefore 2 is the maximum value and minus 2 is the minimum value of the function given. Next question. If the total cost function is given by C of x is equal to 350 plus 12x plus x square by 4 and revenue function is given by R of x is equal to 75x minus 2x square, find the level of output at which profit is maximum. Now profit maximization is possible whenever marginal cost will be equal to marginal revenue. And marginal cost will obtain by deriving C of x and marginal revenue will obtain by deriving R of x. So therefore, let's find out marginal cost. Marginal cost will be 12 because constant derivative is 0. 12 into 1 we will get, and here we have 2x by 4. That is equal to the derivative of the second function 75x minus 2x square, which will become 75 minus 4x. So now here also 2 get cancelled. So we can multiply 2 throughout to remove the fractions. So 12 2s are 24 plus x is equal to 150 minus 8x. So when you shift these two on the opposite sides, we'll get 9x is equal to 150 minus 24. So we will get 9x is equal to 126 or x is equal to 14. So this is the maximum level of output you can reach. Next question. If s is equal to 2t cube minus 5t square plus 4t minus 3, find the time when the acceleration is 14 feet per second square, the velocity and displacement at that time. So here we have a displacement, that is 2t cube minus 5t square plus 4t minus 3. We need to find the time when the acceleration is 14 feet per second square, the velocity and displacement at that time also. First, let us find the acceleration. So since we need the velocity also, so let us find out the first order as well as second order derivative. So we have ds by dt, which is nothing but the velocity. So the velocity can be t cube is 3t square, 3t square into 2 is 6t square minus t square is 2t, so 10t plus 4. And acceleration is d square s by dt square, whose value is t square again 2t, 12t minus 10. So now we need to find out time when acceleration is 14. So using this equation, we can write this as 14 is equal to 12t minus 10, or 12t is equal to 24, or t is equal to 2 seconds. Now second one, we will find the velocity. So velocity whenever t is equal to 2 seconds. 6 into 4 minus 10 into 2 plus 4. So 6 4s are 24 minus 20, which is 4. 4 plus 4, 8 feet per second. So next we have the displacement s. So that is 2 into 8 minus 5 into 4 plus 4 into 2 minus 3. So that is 16 minus 20, which is minus 4. Minus 4 plus 8 is again 4. 4 minus 3 is equal to 1. So therefore the answer is 1 feet. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.